Hello everyone, welcome. Now in this episode, let's design a serverless architecture for National Fuel Pass application. Now this National Fuel Pass application is a recently released application by the Ministry of Power and Energy in Sri Lanka. The main intention is for the users to register for their fuel pass. So once they registered, they will receive a QR code, and then this QR code can be shown to the filling station, and then they can get the fuel. Now, when we go to this particular website, fuelpass.gov.lk, we can click register, and then there's a simple form to add personal details. So here we are required to add the NIC or National Identity Card number, or any one of these, passport or business registration number, and the mobile number. So after filling these two information, we have to get an OTP. So you can request for an OTP, and then the OTP will be received, or the one-time password will be received to your mobile phone, and then you can verify it. So there is this authentication challenge. So if it is matched, then you are able to add the rest of the details like the first name, last name, and the address, and then you can click next. Now let me show it in a different screen. Now here I have these main pages of this application. So first one is you already seen, the personal information section. And once you click next, you will get to the vehicle registration section where you are supposed to add your vehicle number and the vehicle type, whether it's a car, bicycle or so, and then the chassis number. And you have to select whether you want petrol or diesel. And then you can click register. The register button is not here. And after a successful registration, you can log into the application. Here, if I go to this login section, you just have to provide your phone number and click send the OTP. So you'll get a one-time password, enter that, and you will get to the login screen where you will be presented with a QR code, which you can utilize to get your fuel. Now there's one thing that I want to mention. That is, when we are at the vehicle registration page and add this information and click register, there will be a verification process. So in this verification process, personal information like NIC and the vehicle information like vehicle number and the chassis number, so those details will be sent over to Department of Motor Traffic System. This is an external system, I believe, and check whether this information is accurate. If and only if the registration process be succeeded. So that's an external system this application will communicate with. Now, on the very first day that this application was launched, so many people started to register. I think on the day, more than 1 million people started to register for this fuel pass. However, on the very first day, system was unable to keep up with this so many number of requests and started to fail in some areas. For example, this OTP was not received by so many people. And also there were issues with the registration steps as well. So the system was not able to keep up with the scale at the beginning. However, the development team was able to fix these issues quite fast. And on the very next day, everything was operational. Now in this episode, I want to design a serverless architecture using AWS Serverless Services that can scale up to millions of users without incurring too much cost, as well as with good security measures. So let's have a look at the requirements. Now I've categorized them into two requirements, functional requirements and the non-functional requirements. By the way, there are lots of assumptions here because I don't know the nitty-gritties of this particular system. I only assume most of these things by looking at the UI and my experience while getting registered to this application. So these are the functional requirements I have identified so far. So users should be able to register and log in with an OTP. Now, as you have seen, there is no any username password fields. Instead, we have this OTP or one-time password. We can call it passwordless authentication, both in the registration aspects as well as when user logs into the application. Next, users should be able to store their personal information as well as their vehicle information. So after adding these informations, when we register it, the application should verify this use and vehicle details with an external system, the RME system or Department of Motor Traffic system. So after a successful registration, users should receive an QR code. Now here I've changed this functional requirement just a little bit to make sure this system is scalable. Instead of sending this QR code in a synchronous manner, I made that flow asynchronous. That means users do not receive the QR code instantly, but they will eventually receive it. And once the QR code is ready, they will be notified with an SMS, and then they can go ahead and log into the application. And after that, they will be able to view their QR code. I've changed only this requirement. In the original system, you receive the QR code as soon as you register. And I'll explain why I changed that flow into an asynchronous flow instead of being a synchronous flow. All right, and I've noted a couple of non-functional requirements such as the high scalability. I think this is a must. And then the system must be highly secured too. Otherwise, a user can misuse this application or a hacker can hack this application. And then I've added the cost aspects as well. The operational cost should be minimum. So with this functional and non-functional requirement, let me start with the user registration architecture. Now, as I've already mentioned, I'll be using AWS Services to build this architecture. Now here, I'm starting with serverless first thinking because there is this non-functional requirement that our costs has to be minimum. So I don't want to pay for any idle time for this particular system because I understand at the time this system is launched, maybe on first few days, there'll be lots of traffic, but going forward, the traffic could be reduced. So I always check whether we can use a serverless architecture so we don't have to pay for any idle time, but we'll pay for only the usage. And for some flows, if the serverless architecture doesn't fit, I can always use a containerized application architecture. So it will use both serverless and containerized architecture, kind of a hybrid mode. And by the way, guys, there's nothing called this is the best architecture or so. It all depends on your requirements. So there's no any silver bullets. You can design this architecture in a different manner. But let's try to find the best fit for business requirements. So in this architecture, I will explain the decisions as to why I use these services in this manner. So we'll evaluate this user registration architecture against the scalability aspects of it, cost, security, and complexity of it. And of course, it should cater for all the functional requirements as well. So let's start. Now here, the application itself, as you can see, it's a very simple application. So if I'm architecting this application, I would put it into an S3 bucket as an static web application and serve it through CloudFront. So here the reason why I use S3 is it's low cost, probably the lowest cost object storage that you can find. And when we enable the static web hosting mode, it will be scaling automatically for you. So I don't have to worry much about the scalability of our front-end application. And then I use the CloudFront to serve this web application. And CloudFront here, it acts as two things. One, as an CDN, content delivery network with caching support. So when the users are requesting for the website, we will probably create this S3 bucket in Mumbai region because that's close to Sri Lanka. And then the CloudFront will start caching our static web application at the edge locations. Another reason to use CloudFront here is to use it as a proxy. So this acts as a reverse proxy. So it will proxy our web application as well as our backend API. So all the request that is coming from our users has to go through CloudFront. So this gives us another opportunity for us to enable all the security related constructs at the CloudFront level. Now that all the request has to go through CloudFront, if we enable services like WAF or Web Application Firewall, we can mitigate most of the web vulnerabilities. For example, WEF has rule sets which you can define or you can get it from their marketplace that will inspect traffic for top 10 OAuth vulnerabilities. So that's another advantage of having CloudFront as the first point of contact to our application. So when we have CloudFront, we can add security and we can use CloudFront as a CDN. We can enable caching and we can use it as a reverse proxy. A word about caching. When we enable caching at CloudFront level, the cost-wise, it is minimum. We can add caching at many levels. For example, at the outer level, or we can call this is the edge layer, or we can add it at our API level, database level, and so on and so forth. More we move into our application, the caching generally gets costly. So it's always good to have caching at the outer level. And if you want, you can enable at the other levels as well. Okay, so let's have a look at our functional requirement. So one of the functional requirements is that users should be able to register and log in with OTP. So this is basically the passwordless authentication. So here I've used another managed service, which is Amazon Cognito, to handle our passwordless authentication workflows. Amazon Cognito is a managed service and it will act as a user pool to your application. So you don't have to manage your users in your application itself. You can decouple your users from your application. And that's always a good thing because whenever you have so many users, you can scale those users separately. You don't have to scale your application when you have a big user base and it keeps growing. And on top of that, Amazon Cognito is a managed service, so you don't have to worry about the scaling aspects of it. And the charging is also based on the monthly active users. Now, Amazon Cognito supports these auth challenge triggers. For example, we can set up these different authentication challenges. In this case, users are supposed to receive an OTP through SMS and then they are supposed to add the OTP and verify it. So that is the authentication challenge process. And Amazon Cognito user pool particularly have these auth challenge triggers. So we can define these different triggers such as define auth challenge, create auth challenge, and verify auth response. So we can essentially invoke Lambda function in response to these triggers. So when the users try to register, these Lambda functions will take them through the OTP verification process. One will send the OTP and finally it will be verified as well. So once the user's authentication challenge is successful, they will be added into Amazon Cognito user pool and it will return tokens. Now these are the JWT tokens. These tokens, essentially ID tokens and access tokens, will be sent to the front-end application. And in the front-end application, we'll be using AWS Amplify library. So whenever these tokens are being received, these will be stored in local storage and AWS Amplify will handle the token refresh part as well. So when a token is about to expire, Amplify will handle the refreshing tokens using the refresh tokens behind the scene. So you don't have to worry about that. Not only that, but also when Amplify connects with these AWS services, it will use SIGWI for request signing, and that will ensure to call these Amazon services securely. Now, on the other hand, when the user is in the auth challenge workflow, users need to be notified with SMS. For example, in order to send the OTP, we have to send an SMS to the user's mobile phone. In order to handle all these SMS sending part, we'll be using AWS SNS or Simple Notification Service. Now, this is also a managed service, and SNS has this SMS notification type, and that will take care of sending SMS at scale. Now, when user auth challenge is successful, he has successfully verified his token or OTP rather. So then he's able to enter his first name, last name, address, and click next. Now we need to store this information in a user table. So what happens when he clicks next here? We will call upon another API endpoint, and that will also happen through CloudFront. So let's imagine this path is /user register, and we have this API gateway origin attached to this path. So API gateway is a managed REST API, and we can associate request authorization at API gateway with Amazon Cognito. So by this time, the user is created in the user pool. So API gateway is able to verify when a request is received by API gateway, whether this user is already available in Amazon Cognito. If and only if API gateway will allow to call the user register Lambda function. Okay, now let's imagine the OTP is successfully sent and verified, and the user is already in the user pool. So API gateway is able to call the user register Lambda function and will be passing the user information such as first name, last name, and his address. So we can directly save that information in a user table. So the user register Lambda will directly store that information in a DynamoDB table. So after that, a success will be returned, and then he will move over to the vehicle registration page. We'll talk about the vehicle registration page architecture in the other slide, but we want to look at some of these quality attributes and how are we doing with our non-functional requirements. So let's evaluate our architecture in terms of scalability, cost, security, and complexity. I can directly start with the security. As I already mentioned, we can define our security constructs such as WAF, Web Application Firewall, onto CloudFront because this is the first point of contact for our application. And we can block direct access to this S3 bucket using something called OAI, CloudFront OAI or Origin Access Identity, so that users are not able to access this S3 bucket outside the CloudFront. They always have to go through CloudFront. And then, of course, when you are writing your code, the code in the Lambda function, you have to make sure that you do the input validation and follow other coding best practices when you are writing the code. Now, when one AWS service call another AWS service, in this case, when AWS Amplify call Amazon Cognito, we use AWS SDK and it will use SIGWI for request signing too. And the token that we receive from Cognito user pool is also short-lived. Here, usually the ID token and access token lives for 1 hour. And Amplify will use the refresh token to do the refreshing time to time. And at the API gateway level, the request will be authorized with the Amazon Cognito before calling the downstream services like user Lambda functions and user DynamoDB table. So that's the security part of it. So how about the scalability? Now, when it comes to scalability, I've taken a couple of approaches. One thing is, most of these services are managed services. AWS WAF, CloudFront, S3, Cognito, SNS, DynamoDB, API Gateway. Now, most of these are serverless managed services. So they are inherently highly scalable and available as the service itself. But that doesn't mean our architecture is also highly scalable and available. We have to make sure when we are connecting these components or the managed services, we will do it in a way to ensure the scalability and availability in the whole architecture. We should not have any single point of failures. So as the first best practice, we use managed services. We are not going to create these services functionalities by ourselves and reinvent the wheel. We'll let AWS to worry about that. And then we used most of these event-driven triggers. Amazon Cognito has these event-driven triggers. When the users are presented with the authentication challenge, Cognito will invoke these at the time they are required. So we are not managing that. We are letting Cognito to invoke this service or the functions at the time that they are required. We only create the logic and add it to Lambda functions that will be called by Amazon Cognito. Now have a look at this flow. When user information are going to be stored in a database table, we call it through an API gateway, and it will synchronously invoke a user Lambda function, and it will synchronously call or store the data in a user table. So one might wonder whether this is a good pattern. Well, obviously, you might know that databases are inherently not as scalable as serverless functions. Serverless functions can scale up very easily, but compared to that, databases are not as scalable as it is. But however, since we are using DynamoDB and in the paper request mode, DynamoDB can absorb quite a number of requests. But however, we'll be associating some concurrency limit to these Lambda functions. We do this as a good practice because AWS only allows 1000 concurrent Lambda invocation per account. And of course, we can increase this limit by raising a support ticket. So here in this architecture, I would usually increase my account level concurrency maybe up to 5000 or so. But still again, I will add a cap. I will add a maximum concurrency, the Lambda functions level. Here I would say, okay, this user register Lambda function can maximum have maybe let's say 100 or 200 concurrent Lambda invocation. I will also define the same concurrency limits to these functions as well, because I don't want one of these Lambda function to consume entire concurrency that is reserved for an account, and that will suffocate all the other Lambda functions in my architecture, and all the other parts will start to suffer. So as a good practice, I will use this maximum concurrency. For that, I'll be using reserved concurrency for Lambda. All right, about our web application, I already mentioned S3 is scalable. And on top of that, we have CloudFront, and we will cache our front-end code at CloudFront. So when users try to load our application, it will not always go to S3 bucket and serve the website from the S3 bucket. It will be served from the CloudFront cache. So here we have a reasonable scalability at user registration part. Okay, how about cost? Now here we use serverless services, serverless managed services, WAF, CloudFront, Cognito, SNS, DynamoDB, API Gateway, and so on. Now most of these services only charge for the usage. And if our application is not used by users, we almost don't have to pay. Unless, of course, you use different WAF rules that charge you per hour or so. Otherwise, these services like CloudFront, S3, Cognito, API Gateway, and DynamoDB, because here we use pay-per-request mode, we don't really have to pay unless we are using it, including SNS. Now, towards the end of this series, I will calculate the cost for serving 1 million customers in this architecture. Now, in this architecture, I see not only this user registration, but also the vehicle registration architecture. I'm not going to go over that in this video, and also the user login architecture. So let's get back to our user registration architecture. Let's talk about the complexity of this. Now, although we see there are a lot of connected services, this is not a complex architecture. All we have used is these managed services, and we'll attach some Lambda function for executing our logics. And we can use infrastructure as code service such as CDK or the Cloud Development Kit or serverless framework or serverless stack framework, Pulumi, or whatever these abstracted infrastructure as code service. And you can create this entire architecture in within few days. So that's the user registration process. Next, we have to talk about the vehicle registration process. Let's talk about that in the next episode. So in the next episode, let's talk about this architecture where we'll be using choreography and also orchestration patterns. And I will also discuss how can we use queues to control the number of traffic that is going out to our external API, which we do not have control over, and which probably not as scalable as our serverless architectures, so that we don't break these downstream services. So let's talk about this architecture in detail, and I will explain all the design decisions in that video. Thanks for watching, guys. I'll see you soon.